presented by Caltech.
Hello, everyone, and welcome to the annual Feynman Prize seminar hosted by the Caltech Project for Effective Teaching, or CPET. My name is Olivia Harper-Wilkins, and next to me is Rebecca Silva, and we are the co-directors for CPET, a group of graduate students and postdocs dedicated to improving their own effective teaching and helping others do the same. To achieve this goal, we host a variety of events, including discussion groups and seminars such as the one we're hosting today.
It is my pleasure to introduce Brian Stoltz, Professor of Chemistry and the 2016-2017 winner of the Richard P. Feynman Prize for Excellence in Teaching. Brian was nominated by many former students, current students, and colleagues for his long history of effective teaching and mentoring here at Caltech. His teaching evaluations were noted to be universally outstanding, so we thought we'd share a few with you today. So undergraduates have noted that his 9 a.m. lecture is worth, and that he relates current topics in organic chemistry to the biological sciences. Graduate students have similarly noted that his class is awesome, and that taking his course has been a highlight of their academic careers. So Brian, we look forward to what you will be sharing with us today, and we know that your seminar will be totally worth. So please join me in welcoming Brian.
Thanks, Olivia. Thanks, Rebecca. Thanks so much for organizing this and for the very kind introduction. I hope it's worth as well. This is an amazing turnout. It's a great, Bob, to see what people do for a free lunch. Where's Bob? There's Bob. Yeah, thanks for coming. I thought they asked me for a title, and so I thought I'd try to make a title that was incomprehensible to people, like it was for me when I first got here with all the acronyms that people at Caltech use. So that was my title. It's, what could be more fun than teaching organic chemistry at Caltech? So there we go. Not much, in my opinion. It's been just a fantastic experience to do this for now almost 18 years. When I teach, I really love to teach. It's great to not teach sometimes, so that's fine too. But actually, you'll see that teaching is beyond the classroom. It's really something that is encompassed by every bit of our day-to-day lives here at Caltech as a professor, and that's really one of the joys of what this is. So hopefully you'll get a sense of that today. I'm not sure how long this is going to be or how well it's going to be received. I have no idea. This is a one-off. I've never given this talk before, so we'll see how it goes. Yeah, it was like any lecture in a classroom that's a new course, putting something together. You're kind of winging it the first time, and that's what I'm going to do today. So we'll see how it goes. First, I do want to say some thanks to a lot of people. Students, postdocs, faculty, staff, administration, the Feynman Prize donors. I'll talk a lot about the folks up here, but certainly the administration and the donors have to be recognized. I'm looking forward to meeting some of the donors in a couple of weeks at a dinner that's been planned for a while, so thanks to all of them. When I received this about a year ago, Ellen Rothenberg, who was a former recipient of this, sent an email and just said, this is an award of pure happiness. And I feel like I've never forgotten that sentiment, and I think she's completely right. It really is. It's a real joy. And certainly it's an incredible honor to be associated with one of the legends of our institution, and that's been something that means a tremendous amount to me. And certainly the legendary list of other recipients of this award are also humbling. And just want to shout out, so congrats to our terrific colleague, Harry Gray, for being the recipient this coming year, long overdue. So congrats, Harry. I'm really happy that I don't have to go after you. So anyway, congrats and enjoy your pure happiness, Harry, as well. So, I'm sort of want to run with this theme a little bit. It really was, a tremendous surprise and an honor. And But it has to do with the happiness of winning, but the happiness of being a teacher here at Caltech. It's really a three-pronged kind of aspect to teaching. There's classroom teaching, of course, and I think that's a lot what most of us think about when we talk about teaching. But there's out of classroom teaching as well. There's mentoring that goes on in the laboratory, and of course that laboratory mentoring is fueled by research, and I think that you'll see that these are intertwined in essentially all aspects of teaching. And it's at the center of that, of those overlapping areas that I think is really that happiness, right? And I think that's true for most of us, that our lives are incredibly enriched by the people that are around us, incredibly enriched by what we do in the classroom, but by the students that we interact with, both in the classroom and in our laboratories, and the ideas that they bring to bear on problems that we're interested in deeply. Even beyond that, there's more. There are outside activities that go beyond those three. Things like outreach to local schools, and you'll see some pictures of those kinds of things. Activities that are really beyond science, beyond chemistry, but are interacting with our students at the university and the local community. And of course, the family, I think, plays a huge role in everything that we do. And so these are bigger, broader circles that go outside of the three that I've drawn in here, but it really all brings together, I think, a person's general happiness, and I am certainly one who's am a pretty happy person in general. So I just want to start with a few opening remarks about teaching. Teaching is hard. It's a challenge. There's no question about it. I think it's something that if you want to do it well, it takes a lot of time, effort, deep thinking, planning, time. Did I mention time? It takes a lot of time to put together a lecture. This was something that, when I first started teaching here was stunning to me. And putting together an hour-long lecture often took 10, 12, 14 hours for that 1 hour of classroom time. And it hasn't gotten any better, over a long period of time. You put together a new lecture, it takes an incredible amount of time to do that. We'll see, the course of today, how well I've planned this all out. One thing is, don't be afraid to try new things. This lecture is a new thing. Oftentimes, you want to try to introduce new things within a classroom setting. And I would encourage students to do that as young faculty. Try something different, Try an activity. Try to flip a classroom from now and again. It doesn't always work out. In fact, most of the time it doesn't work out. But students will let you know. So my plea to students is, please be patient. When a professor is trying to do something different, be patient with them. Work through it. Let's see if it has any value at all. And if so, there is that feedback loop that we have here at Caltech, where you can actually, either mid-course, we have these ombuds meetings, or at the end of the course, these TQFRs, you can say, that class was okay. It was but there were some things in there that were problematic, and the prof should try it differently. And if the professor's taking that advice, we genuinely, I think, try to revamp things and make them better the next time. But we only fail if we actually try to do something different, I think. And I think it's important to keep in mind that, teaching and learning actually go hand in hand. Oftentimes, professors think they're going to teach this great lecture, but they forget that students actually have to learn something about whatever it is that they're teaching, and that they actually have to try to absorb it in a way that's meaningful to them, and that they can draw connections to, and that they can actually remember what they heard in the lecture. So, these go hand in hand, and it's important to remember that both are challenging. Teaching a lecture is challenging, but absorbing it is also not easy. Particularly at the level that we expect our students to be at an institution like Caltech. There are lots of other aspects to teaching that are great. Overall, it's an incredibly rewarding process to watch a student develop, to watch a class pick up concepts that you really didn't think they would be able to. I remember I ran an exercise, a flipped classroom in a Chem 41A class. This is the first term of sophomore organic chemistry, and the exercise eventually built up to the point where the students at the end of the lecture could understand what double diastereomer selection is. That's a concept that we don't usually introduce until an advanced synthesis class in graduate school. But they were able to tackle that by a sort of step-by-step interactive learning approach. And that, for me, was an incredibly rewarding experience that it worked out that well. But teaching, it's about caring and patience, respect for the students, and overall enthusiasm. If a professor shows no enthusiasm or a teaching instructor shows no enthusiasm for the course, how on earth do you expect your students to want to do anything to do with that? So those are all really important. I've always viewed this as one of the more important aspects to this as well. It's a chance to convey your own passions. Again, in your area of expertise, if you're not passionate about what you are doing, why would anybody else care? And so I viewed, for instance, the first time I taught the synthesis class, which I'll talk a little bit more about later at Caltech, I love synthetic organic chemistry. And I felt like it was my job to make everybody in the audience that day, that term, love synthetic organic chemistry and want to be a synthetic organic chemist. And I felt like if I didn't convey to them what I wanted them to know, who was going to teach them? And I think this is important. Teaching can be disruptive to one's reality. Oftentimes you hear something in a lecture that makes you think about the world in a really different way. And so the instructor is the one who's hopefully disrupting your reality, and hopefully the students then become inspired to create a new one. I think those are kind of interesting things to think about for teaching. But overall, I view this as really an important responsibility. It's a responsibility of us at an institution like Caltech, and it'll be your responsibility as you go off to wherever you go off to, whether you're in education or in industry or some other area. It's your responsibility as well, to continue to teach new people new things. So in the summer of 2000, a long time ago now, I arrived at Caltech. I was fortunate at Caltech to have that first day I showed up, maybe the second day after I plowed through a bunch of boxes in my office that Joe Drew had put in there of things that I had ordered. I couldn't really open the door. 4 graduate students showed up, Sarah Spessard, Neil Garg, Jeremy May, and Eric Ferreira. And about a week later, a pre-frosh named Megumi Abe showed up in my office. She was a month away from matriculating at Caltech and said she wanted to start doing research in my lab. So this was the group of students in that summer that set up the lab and got things going. And I feel like with those students, I had probably the closest one-on-one interactions of any of my students over all the time that I was here. And some have gone on to do great things and are recognizable names. Others, you may not recognize their names, but I certainly valued their time in the lab and have valued them and their friendships since. But that was, that I think from on our website you can go and look and see what happened from 2000 to 2018. There's a lot of information out there about those years. What I think probably most people don't really know about is what happened before 2000. So I thought I'd give a little bit of personal introduction and history to you. So we'll see how valuable this is. But I think ultimately the point of this is that I want to convey, particularly to the students, that everybody's path is different. Everybody starts from wherever they start and they end up wherever they end up. But how you get there is a function of all the interactions that you have, and in particular, all the things you learn along the way. And so I've always had this feeling that if I can do this job, anybody can do this job. So I think that's called the imposter syndrome. But I'm waiting to be found out. So where did it start? I was born in Philadelphia and raised in a place called Havertown, PA, which is the second suburb past 69th Street in Philadelphia. So you take the L to 69th Street, and then you take a bus 2 more towns to get to Havertown. And I had a pretty ordinary childhood, I think, for the time. But I remember thinking even early on, about teaching. And so I thought I'd show a couple of pictures of teachers from that time. This is Mrs. Angelo and Mrs. Elko, 2 of my favorite teachers from elementary school. We went to Manoa Elementary School, strange name for a school in Pennsylvania, but that was the town I grew up in. And I asked this question, why become a teacher? And even at the age of 7 or 8, I thought I could do it better than they could. So I distinctly remember in their classrooms getting assignments and thinking to myself, this is a really stupid assignment. If I were running the show, I would do it differently. And so, in retrospect, it kind of makes a lot of sense, the profession I chose. But there were a lot of early influences, and I lived, here my parents up there, that's my older brother, Kurt. We lived in a duplex with my grandparents, my Nana and Papa, so there they are, that's me, a little older than that, that's me also. At some point my sister came along, Megan, she was born 8 years after I was, so she was really a baby sister. But my grandparents had a tremendous effect on me. That's my Nana dressed up in some silly pajamas at Christmas time. She's the one who threw batting practice to me. Many of you know I love baseball, and she spent hours and hours in our backyard throwing batting practice. She never asked me to pitch to her, which was good. We had a nice extended family, my Aunt Pat and cousins. So those were, certainly, very early influences. Here's some more recent ones. I should point out, my mother was really an extraordinary person. She moved to the United States from Germany when she was 15. She came here by herself. She had an aunt and uncle who lived in Philadelphia, and that was the purpose of her visit. She was supposed to come for a year, take care of her then dying aunt, and, kind of transition her, what would be widowed uncle into whatever he was going to do next. I think the thought was he was going to die shortly after his wife did. And that was in 1956. He didn't die till like 1986. He eventually even lived with us at some point. But she was supposed to come for a year and ended up staying forever. And was really just an amazing, amazing woman. This is later in life with two of her surviving siblings there. And this is very later in life walking with my son Harry. Many of you know my wife Erna and Harry and Teddy in their baseball uniforms. These are influences that continue, in my life. So, it's clear that family plays a huge role in things that we do. And it really did in everything, in my life from the time I was, this old till today. So thanks to all of those people for everything that they've done over that time. Okay, so back to the life history. So in 1988, I graduated from high school. These were a couple of really frightening-looking teachers, that big. But these were a couple of chemistry teachers from Haverford High School, Mr. Hulse and Mrs. Peterson. So Ray Hulse was a really unusual guy. You can see this is from the yearbook. He's involved in lots of things. He was the ski club advisor or whatever. He went on some foreign exchange trips to Germany with our German class while we were there. But he was also the chemistry teacher. He taught, general chemistry and AP chemistry. Among the memorable aspects to him was that he every year would teach an entire lecture standing on his head. So that was, classic high school. Anyway, pretty funny guy, very unusual, but memorable and inspiring in some strange way. Mrs. Peterson, she also taught, general organic chemistry, but when I was a senior, she did something really unusual. She just decided that she would teach a year-long organic chemistry class. So as a senior in high school, I took a class with about 4 or 5 other students, and we were just exposed to an entire year of organic chemistry. Something that, as I would learn later, was really a very unusual experience for a high school student to have. And so, I'm not sure I loved organic chemistry as a result of that, but certainly the exposure made taking organic chemistry later easier, and I think that helped to then allow me to have the time to appreciate the beauty of it. So I really, in retrospect, owe her a tremendous debt of gratitude. Something else happened in high school that was really kind of cool, which was the Science Olympiad. So this was a newfangled thing back in 1987, 88. And my high school was ecstatic to participate in this. And this was a national thing at the time. And so it turned out, we competed, I think in 86, 87, didn't really do that well. But in 88, the year I was graduating, we actually won the national championship. There we are at the top. That's our, whatever that means, but that's our rank. We went to this, national Science Olympiad tournament, competed for this thing. It was awesome. So you may think, given where I'm at standing here now that I played some really critical role in the chemistry aspects of this science Olympiad. Turns out, this may have been the closest I came to chemistry at that time. These are 55-gallon drums, presumably of some sort of solvent. But I didn't do anything involving big-scale chemistry with those 55-gallon drums. I sawed them in half in my basement and tried to bang them into steel drums so that our so-called physics band could play America the Beautiful. We did. We could play America the Beautiful on these things. It sounded terrible, but we were probably among the most creative instruments. You had to make instruments from scratch and play America the Beautiful in this competition. But I think that maybe that's the only thing I have in common with Professor Feynman is an affinity for the drums. I did at the time play the drums a lot, and so I was excited to make a steel drum. But there was no chemistry, but this was exciting, and it was exciting to meet so many kids. We met lots of kids from all around the country that were interested in science, and I think that, again, having great teachers that were so involved and engaged to do this with us for hours and hours and hours and schlep us around to all of these competitions. Of course, winning was fun, but that was really something that was extraordinary. So after that, as I said, I spent most of my time playing the drums, not really studying in high school. And so I went to a college in Western Pennsylvania that probably nobody's really heard of, Indiana University of Pennsylvania. So this is a school that is in the state school system of Pennsylvania. There's the top tier schools in Pennsylvania. Those are like Pitt and Penn State and Temple. I think they're at the top. And this is like the next tier down. So this is sort of, it's not much, no, it's not a very good school. It was okay. But it was a big school. There were like 15,000 students who went to this school. And importantly, there were lots of students who were like pre-something, pre-med, pre-dentistry, pre-whatever. So there were a lot of students who had to take chemistry as a core course. But there were very few chemists. In fact, I think in my graduating class, again, 15,000 students at the school, there were 6 chemists graduated in my class. So not a very popular major. But the chemistry professors, because there were lots of them, if you were interested in chemistry, they really took you under their wing. And the person who took me under his wing most was this guy. Again, frightening looking, this big, but Professor John T. Wood. So that's Thomas for the middle name there. Wood had been a graduate student at Pitt and a postdoc at Yale with Jerry Burson. And then he went back to his alma mater, which was this place, IUP. And what was interesting about IUP, again, I think in retrospect, IUP was the Pennsylvania Normal School. So a normal school, for those who don't know, is what was a teacher's college. So there was really a long history of teaching at this school. And in fact, there were a lot of excellent instructors at this school. I half jokingly say that this wasn't a very good school. It's not in the sort of schools that you would dream to send your child to, I don't think. But it was actually a fantastic school for me. This guy, though, was an extraordinary teacher among extraordinary teachers. He set out, again, with this passion to make people love organic chemistry. He taught us extra evening lectures. He had this unusual testing style, which essentially meant putting you in a room on a Saturday morning, and you spent as long as you needed on the test, right? And often that lasted until 7 or 8 o'clock at night. He'd buy you lunch and buy you dinner, but you had to stay till you were done or happy with the test. The frightening thing about his tests were that you really didn't know anything until about hour 6. You couldn't answer any questions until deep into the thing, and then finally you started clicking, and then all of a sudden you could sort of answer these. Or not. I had some of those experiences as well. But he offered tremendous advice and was just such a thoughtful person. Advice like, when you go to graduate school, actually care about your classes, because that may be the only interaction you ever have with the professors. Those professors, you'll have lots of interactions with your advisor, but you may never interact with your other professors that much. And so if you blow off their class, they'll think that they won't think very much of you. That I thought was really good advice, and I noticed not all of my classmates had received that advice once we got to graduate school. And the other thing he did was exposure to a research group. This was a foreign concept to me. Neither of my parents had even attended college, let alone thought about graduate level research, and he exposed us to that. But his entire persona was centered around gearing us up for what he called the BTU. You know what the BTU is, Harry?
Well, I know one part of it, but what the hell is it?
The big time university. That's what he would tell us. You're getting ready for the big time. So
Well, I've learned something.
there you go, the BTU.
Even at my age, I can learn something new.
So I was gearing up for the BTU, but as part of that, I decided to spend a year abroad. And so I actually went to work for a big chemical company. This is Bayer in Leverkusen in Germany. At the time, this gigantic sign was made up of incandescent light bulbs. And there was actually somebody employed by this company whose job it was to change the light bulbs. That was it. That was the person's job. This was an amazing experience. It was chemistry on the big scale. I remember walking to work one day past a tanker car of acetone, just said acetone on the side of this railway car. Just an amazing scale stuff. There was this building off in the distance that was pristine white. You could see it. All the other buildings were gray, kind of ugly. There was this one building that was just beautiful white. I said, what goes on in that building? And they said, that's where they make titanium dioxide. It's just an amazing experience. But this was, an experience of industrial research, and it was really a terrific internship. We then, after that was over, I actually then spent about 10 months in Munich in the south of Germany. That's just a beautiful picture. And on a couple days a year, it actually looks like this, where you can actually see the mountains in the background. Just a spectacular place. And I went there and just sat in on graduate level classes in chemistry and had just an amazing experience. And came back completely solidified and ready to move on to the BTU, which in my case was Yale. So started graduate work at Yale, met this fantastic person, a different John Wood, in this case L for Lewis, just an odd coincidence, but everybody named John Wood is amazing. John was a first-year assistant professor. I joined his lab despite all of the advice that I'd received not to join an assistant professor's lab. I think it was the best decision I ever made for sure, and I would encourage anybody to join a young person's lab. It exposed me to things that I think in an experienced lab you're never exposed to, ups and downs, starting projects from scratch, all kinds of things. But above all, what John did for me was he gave me the confidence, to have my own ideas and push those forward. And I think, if an instructor or a teacher or a mentor can do that for you, then you're golden. And so that was him. And he has never stopped caring. This guy is just unbelievable, an absolutely unbelievable person. Here's some other notables from the time, at Yale. You may recognize some of them. Jerry Burson, who was my chemical grandfather. Ken Weiberg, who taught a spectroscopy class. Hartwig taught organometallics. Alana Shepharts, who a lot of friends joined Alana's lab and introduced me to chemical biology. Mike McBride actually had a lot of funny stories about my undergrad advisor. Fred Ziegler taught us synthetic chemistry. By that time, I was married to Erna, and Erna and I had the fantastic experience of being able to house sit for Harry Wasserman and his wife, Elga. And so that's when Harry met Harry, my son Harry, who, we decided while living in their house that if we ever had a boy, we were going to name him Harry. And there he was. And of course, I was lucky enough to have a fantastic colleague named Harry. I've always said if this Harry had turned out to be a jerk, we never would have named our kid Harry. So.
Wow. If I'd known that, I don't know what I would have done.
You're the Hungarian grandfather, Harry. You always will be. So this was just an amazing experience to live with them. Occasionally they came back and shared the house with us. We said we would leave, and they said they would have none of it. So we sat there on the couch listening to...
By the way, Brian, I have a question on the previous slide.
Yeah, this one.
What's the story of that really ugly-looking coat?
This?
What's that coat?
That's not a coat. That's a flannel shirt. Yeah, I think I burned that when I left Yale. It was saturated with solvent. No, I'm pretty sure I bought that, but it matches his tie pretty well. Right? So that was a great experience at Yale. And then I went for a postdoc with E.J. Cory at Harvard. And Cory, was an incredible advisor, and really at the opposite end of the spectrum of my graduate advisor, right? My graduate advisor, an assistant professor at the beginning of his career, E.J. was a seasoned veteran who had been at it for 50 years. And E.J., I think in a lot of ways is underappreciated for teaching. He literally wrote the book on how we do synthetic organic chemistry now. I was fortunate to have the opportunity to actually serve as his teaching assistant for the last term that he ever taught his synthesis course. And so to work with him, and I was the only TA, it was great to work closely one-on-one with him to appreciate the level of detail and thought that went into his lectures. Was extraordinary, particularly at somebody, in their last, this is it, he could have just mailed it in, but he really didn't. And so that's a picture of me and EJ on my last day. This is about 10 years later. Not a lot changed other than the colors of our shirts, but that was on his 80th birthday. He's now 90 and still active, so really an amazing guy. And here's a little bit of sort of what it was like at Harvard at the time. There were no digital cameras, so that was an old picture. That's our group back then. Our group's assistant, Patti Gorman, was an amazing person, kept the group running. And Patti was a funny person. I'll tell one Patti Gorman story. Patti, had to do all the group ordering. And EJ is a little bit of a miser, I guess, in some ways. He's very, very frugal. We'll say that. So if Patti over-ordered, EJ would get upset at Patti, right, rather than getting upset at the group. So it was her job to keep the group in check. And so she came out one day, and there was somebody down the hall in our lab who was really not being very nice to Patti. And she said, does this guy really need this chemical? And my lab mate and I looked at each other and said, well, he could probably make it. All he has to do is buy this one thing, and we've got this stuff. You just have to do a Wittig reaction, and so she walked down the hallway and gets in this guy's face and says, all you need to do is a Wittig reaction to make this stuff. I don't think you need to order this. And she walked back into her office with a big smile on her face. And this guy was dumbfounded. It's like, oh my God, even his assistant knows how to do chemistry. So Patti was awesome. My mother was an administrative assistant then, so I learned early on how not to treat an administrative assistant. This is Yoshi Kishi. Kishi was nice enough to let me go to his group meetings, as were Eric Jacobson and Dave Evans. Dave's, I think Dave is certainly somebody who is well known to many of the colleagues here. Dave was an incredible educator and really taught me, I think, the power of, I would say, perfection in presentation. I'm not sure I've ever lived up to it in any of my lectures, but he was one who was a stickler for perfection. And his students would deliver these Friday afternoon literature seminars that were just immaculate. And that was all, I think, came down from Dave's direction. And he taught this legendary course, Chem 206, that the notes float around. There's no book. We always hoped that there would be a book, but these notes have floated around for decades now. And I hope that if you're interested in synthetic organic or organic chemistry in general, that you've taken a look at these notes. Just again, a tremendous educator, and I think many of us have benefited peripherally, if not directly, from Dave. And then there's Andy Myers. So Andy had been a Caltech professor for I guess maybe about a decade or so, and then moved to Harvard in the late 90s. And I, as a naive student or postdoc, went and knocked up on Andy's door and said, Andy, what do you think about this Caltech job? I'm going to apply. And he looked at me, all he said, you should kill to get that job. So I did. And I've been here ever since. So there we go. I don't know. So, this slide is too small to contain the people that I've been affected by at Caltech. Many of you are in the audience. Caltech's an unbelievable place. I don't need to tell, hopefully don't need to tell any of you that. It's a place filled with extraordinary colleagues at every level. Here are some of my faculty colleagues that I've interacted with, taught classes with, performed research with, and otherwise interacted with in various ways. Just absolutely some of my favorite people in the world on this slide. And again, as I said, the slide is too small. I'm only showing CCE colleagues. They're colleagues from all over the Institute that I could put on here as well. I do want to highlight a few things, though. First, I want to highlight the third floor slinger. This is our assistant, Lynn Martinez. She's over there in the audience. Lynn keeps the entire production running. So, thanks to Lynn. This is a picture with her late father, who she also kept running for a long time. Over here is Scott Virgil, who's sitting in the front row. Scott's one of my dearest friends. Also on the third floor, runs our Catalysis Center. He and his wife Silva are like aunts and uncles to our kids. And then there's Sarah Reisman, and that's Sarah with her lab some years ago. Again, there's John Wood. John was also Sarah's advisor, so is really chemical grandfather to the whole floor. Sarah's been an awesome colleague and is just incredible in every way. So the third floor slinger is really a special place. I hope that the students realize how special it is. Most of them realize it after they've left. They write back and say, well, oh no, it's different. It's different wherever I'm at. It's really a special environment, and it's an environment I think that is open and is welcoming to new people, and is one that is built on this mentor-mentee relationship at all levels. So thanks. Another person I want to highlight here is somebody who only I think my colleagues and maybe not even all of my younger colleagues would know, and that's Nelson Leonard. Nelson was here for the first 6 years that I was at Caltech. Nelson had an early career, which was, rose through the ranks to full professor or university professor at the University of Illinois at Urbana-Champaign. And then late in life, moved to California because he fell in love with a woman that Jack Roberts hooked him up with. Maybe Edith Roberts hooked him up with. But Nelson was an amazing colleague. I'd been at Caltech for about 2 weeks, and Nelson came down to my office and said, I'm an old man. I have no real power at Caltech. In fact, I don't even go to faculty meetings, although they've been nice enough to allow me to go. Feel free to come by my office and talk to me about anything. And that was an incredible gesture on his part. And of course, I took him up on it. Nelson had been EJ's senior colleague at University of Illinois and actually had been the faculty member who pressed to hire him. I think he was chair of University of Illinois when EJ was hired there initially as an assistant professor. So I had a deep affinity for Nelson, and we talked about all sorts of things, ranging from teaching to writing manuscripts to new projects. And at the end of these discussions that I would have with Nelson, I often would say, thanks, Nelson. And Nelson's pat response would be, there's nothing to thank. It's just being a colleague. And so I think Nelson, more than anything, taught me what it's like, what it means to be a colleague. And he certainly was a fantastic one here. At Caltech, I've been a part of teaching a lot of classes, and I think that's, again, primarily this Feynman Prize has to do with coursework and teaching classes, and I've ignored it completely up to this point. But I've been lucky to be a part of teaching a lot of classes. Some of them I've enjoyed more than others, and I'll just highlight a couple of the ones here that I've thought were pretty fun. So recently we started this thing, Chem 149. This is a workshop, basically. It's a tutorial, and I say thanks to Greg because this was really Greg's idea. When he came here from MIT, he said, our first year students at MIT had this boot camp, this workshop on mechanism. Why don't we try something like that here? And I think we all agreed that sounded like a great idea, and so we started to do it. And I think Sarah and Greg did it for a few years, and more recently, Greg and I have been sharing the duties. And this is a really small group of students, something like 6 or 7 students. We meet 3 times a week for about 2 hours each time, and we just go through mechanisms. It lasts about half a term. And this last term, these pictures are from just last semester. This clever group of students convinced me to take class outside one day, which I thought was a joke, but we ended up doing it. And then it was so much fun that the Caltech press people got a wind of this somehow and actually asked us to go back and stage it. So these aren't even real pictures. This is terrible. These are staged after the fact examples of teaching outside with sidewalk chalk. Kind of amusing, but anyway, that's been a really fun experience to do, and I think has allowed me to get to know students better. I think that's a great vehicle for doing that, and so I hope that we continue to do that. A couple of courses here. One's a real course. One was not really a real course, but I'll talk about that one first. This was something called OMCAS, Organometallic Chemistry and Synthesis Workshop, that Jonas Peters and I decided to do in the fall of 2000. This is my first term here. This is the beginning of Jonas's second year here. And we just decided we would offer this as an evening course. And we did this on Monday nights for 2 or 3 hours, back before I had group meetings. Now I have group meetings on Monday nights. Before that, we did this. And so that was a really fun experience. And it was a nice experience to interact one-on-one with one of my colleagues, but also somebody who had a deep knowledge of something other than synthetic organic chemistry. And despite our best efforts, that's Jonas wearing an organic chemist t-shirt there. I don't think Jonas ever gave me that shirt back, but that's okay. He must like it so much. In any event, that was a really fun experience back then, and I think the students just ate it up. It was amazing the enthusiasm that the group of students in the fall of 2000 had. And I'll talk more about that in a second. Some years later, 2009, Bob and I decided to do something similar. There's a picture of Bob recently. I think that's your birthday this year. It looks like it anyway. That's a metathesis cake. Bob and I taught this class under this advanced topics thing in the winter of 2009. I think probably because Sarah started taking over teaching synthesis in the fall, so I needed something to do. And so Bob and I just decided we would do this. And I think we still describe this as the class that almost killed us. This was a brutal class because it was new, so Caltech students ate it up. They loved it. They showed up in droves. Not many of them registered, as is normal. Most of them just showed up, and the postdocs showed up, and some faculty showed up, some staff showed up, and decided to listen in to hear what we would have to say. And we wanted to keep this class current and relevant. And so we were trying to teach really up to like the current literature. So we were pulling papers off ASAPs and trying to create lectures. And I remember distinctly being in my office till 4 or 5 o'clock in the morning, the day before, the day of a lecture, having worked on these lectures for many hours, only to show up to class and actually have the person who did the work be sitting in the audience, because it was a bunch of Caltech postdocs, right? So they're at the cutting edge. It was an amazing class. We got through it. We haven't offered it since, mainly because it's now outdated and we'd have to go through this again. Anyway, it was a great experience, and it was fun to teach with Bob, because Bob had a lot of stories, and unfortunately, most of Bob's stories ended with people dying. I guess that happens, but anyway, that was a really fun experience. But really, the two mainstays of my experience at Caltech teaching have been Chem 41, or Organic Chemistry series, and Chem 242, the Chemical Synthesis series. And even within those, mostly Chem 242A, the fall term, and 41C, the third term of sophomore organics. So I'll start with 242. This is a snapshot of the syllabus from the fall of 2000. This is my first foray at teaching ever. And so here's the syllabus. Now, the syllabus, in structure doesn't look that different from the syllabus that I gave to the students just last term. But in practice, we actually made it through this syllabus. This is a pretty ambitious thing. We had 2 midterms and a final. The exams were just like my undergraduate advisor and still are, 10 hours each. We actually had 2 mini proposals that were scattered through the course that were due at various points. There were 7 problem sets. So aside from the 2 weeks of the classes, there was Thanksgiving week. Every other week had a problem set. We'd go through those problem sets on Thursday night problem sessions. The Warren book, which is a workbook on synthesis, that was required for undergrads, but of course anybody who's taken the class knows that if you're a grad student and you don't do it, you're at least going to get a lot of points off, and I'm going to tell you to do, Warren. There were Synthesis Fridays, which I nowadays skip a lot of times. We went through every one of these Synthesis Fridays. It was pretty ambitious, I think. It was aided by the fact there was a hunger for this class, right? Because nobody had taught this class for at least 2 years by the time I had arrived in 2000. So there was a backlog of students who were interested. And there were 36 organic students and something like 15 inorganic students who entered that year. So it was a crazy class. It was also aided by the fact that there were no other classes on Monday, Wednesday, Friday until noon. So that's how I got through the material. We basically just started at 9 and kept going until we were finished. And nobody seemed to mind. Nowadays, we do this a little different, and I think in retrospect that was nuts. But the course is overall not that different. But I think with age, it's gotten a lot slower and a lot more digestible. Maybe even too slow, but anyway, that's 242. 41 has been another real fun course to teach, and this is a plug to my colleagues who don't like to teach introductory courses. I'm going to try to show you some selfish value in teaching these courses. A lot of times professors only want to teach advanced topics, or they only want to teach what they're actually do every day. But I think teaching these introductory level courses is actually a great thing, and there's a lot of value in it. And because of this, right, you learn something new every time you teach. I don't know who said that, but somebody, I've heard that many, many times. That's, I think it's true. So I'm going to show you a lesson that I learned the first time I taught Chem 41C in the spring of 2004. And I often describe this as my first Caltech moment. So in 41C, at some point, you have to draw a lot of structures. And one of the most complicated structures to draw as a young organic student is what we call a chair cyclohexane. So there's cyclohexane as we typically represent it, right? All of these are carbons. There's these inherent, obvious hydrogens, I guess we call them, attached to that. So this is a shorthand. But of course, cyclohexane isn't flat. It doesn't look like that. It's actually more like this. And this is supposed to look like a chair. I've never understood why that's a chair, but that's a chair. I guess you can lay down on this chair. It's more like a bed. Anyway, so that's the chair. And if each one of these carbons is tetrahedral, then that means that all of these hydrogens are coming off in space in a different way. And there's a specific way to learn how to draw these things, where you draw parallel lines. It's a series of parallel lines, and you have to be able to do this quickly, and you have to be able to do this in a way that's discernible to somebody else. And so my point in the first lecture to these students in Chem 41C was, you really have to practice this. It takes practice. You're going to have to draw all the time. Chair cyclohexanes. Get out of the shower. If there's a foggy mirror, draw a chair cyclohexane. Connect a few of them. Draw as many chair cyclohexanes as you possibly can. So on the second lecture, this is what I found as I entered 153 noise. All 9 blackboards covered in chair cyclohexanes. Some of them were really pretty. Some of them were cyclohexanes in cyclohexanes. Some of them got kind of ugly. But all 9 boards were covered, and there was nothing you could do but just laugh and take a picture of it. Eventually, we erased those boards and got to work, but that was amazing. And it just was this kind of thing that I think only happens at Caltech, right? You have these unbelievable students who, will nudge you and push you and joke around with you, but at the heart of it, they're pretty into what you're trying to teach them, and they want to learn, and you want to learn. So that's just was awesome. That was a really fun moment. But occasionally, teaching these introductory courses, you have a big impact on your own research. And so I want to highlight, this is the only chemistry in this talk. Early in 2004, we were working on a synthesis problem that centered around this natural product phosphetamine, and a key intermediate that we wanted to get at was this thing shown here, and I've kind of drawn it in its flat representation below. And you'll notice that this has an all-carbon quaternary center. So for anybody who's an aficionado and excited about the kinds of research that my lab does, or a member of my research team, you'll recognize that as something that we like to do. And the student involved in this is now a professor, J.T. Moore. That's him there at his hood. He was trying to make this compound, but he was also a TA for Chem 41C. And at the time, the synthesis of a compound like this in my lab would have gone by this kind of sequence. We start from the core, we would enolize this and alkylate that with whatever the side chain we needed was, so in this case a carboxymethyl group. Then we would enolize that and install some group here that would allow us to do what was our newfangled reaction, which was this asymmetric decarboxylative allylic alkylation, a mouthful. But we needed to set up that chemistry by enolization, particularly of this position here, to access compounds of this sort. But on this particular substrate, we were having trouble. We would access about a 1-to-1 mixture of these two compounds. The one below would eventually lead to an unwanted byproduct, an isomer of the compound that we wanted. And all of this chemistry, I said it very fast, but it all progresses, at least the catalytic chemistry, through a decarboxylation event. And in Chem 41C, we actually teach our students, I think, what is their first exposure to an organic decarboxylation, which is not at all from an oxygen-bound carbonate, but from a carbon-bound carboxylate. We teach them this reaction, in essence, where we decarboxylate a 1,3-dicarbonyl, a beta-keto acid, to decarboxylate to generate an enol, which then protonates. But we wondered if we could take advantage of that in the context of this synthesis. So we turned the chemistry upside down as a result of that Chem 41C moment. Instead of alkylating first, we enolize and acylate. We install this acyl group. You now have a big pKa difference between the proton at this position and the protons over here. So you can enolize and install that side chain however you want. And then the key is that you take this compound that has a quaternary center, but is a mixture of stereoisomers. You treat it with our catalyst. It loses the allele, loses CO2, generates the enolate, and then reinstalls the allyl group in only one position as a single enantiomer or highly enantioenriched. So we solved the problem as a result of an inspiration that came directly out of Chem 41C. This left us with a new problem, which was, what the heck do we call this kind of weird reaction? We take something that has a stereocenter, we get rid of it completely to a flat intermediate, and then reinstall it, in each case breaking and making a CC bond. And so, of course, I relied on my colleagues. I went and talked to Dennis Doherty, and he said, so you ablate the stereocenter? And I said, yeah, it's a stereoablative reaction. And there was a new term. Thanks, Dennis. So in the last couple of seconds, or minutes, I'll just highlight, ultimately all of this is about students, right? It's how do we keep students engaged? How do we inspire them? How do we teach them? How can we take them from point A, to point double Z? Here's just a smattering of a few students who have, fun stories over the years. Neil Garg, my first graduate student, never ran a flash column. Now he's a UCLA professor. A shout out to Neil. He's the 2018 recipient of what's called the Chemistry Prize. This is a national teaching competition that comes with a $250,000 check. Pretty amazing. That's him sitting next to Ice Cube on a plane. Eric Ferreira, he was another early student that you saw in that picture. I'll never forget Eric in a subgroup meeting, our group's first ever subgroup meeting. He's standing at the blackboard writing, and it's really messy, and I'm saying, Eric, what does that say? He says, oh, I forgot. And he switched hands. He was so nervous he forgot whether he was right-handed or left-handed. This is Raisa Trend. Raisa was an early student, had actually been an English major as an undergraduate and turned herself into a fantastic organic chemist. She was deeply interested in mechanism, something my lab had never really worked on up to this point. But it was fantastic to have an English major in the group. She taught us all how to write papers. That was terrific. Randy Kim and Megumi, I already mentioned Megumi. There's Randy, another early undergraduate. They were both student athletes at Caltech around 2001. Randy, I often tell, is my favorite Caltech athlete story. Now, things have changed a lot, I know, here. But at the time, this was typical, I think. Randy came into my office, said she wouldn't be in the lab very much because she was going to be on the basketball team. I said, wow, that's amazing. NCAA basketball, great, good for you, Randy. And she says, yeah, I'm still trying to figure out the rules, but as far as I can tell, as long as you run down the court and do this, you're okay. So times have changed. Julius Su was telling me that he was writing code too much. I thought that's probably not the right lab. He went on to join Bill Goddard's lab and is a teaching professional now, writing code to figure out how to teach better in a program called SKIES. Nat Sheridan came to my office and said, I want to do organometallic chemistry in your lab. I thought, okay, take advantage of this. That's an unusual thing. He's going to teach me a lot about organometallic chemistry, and vice versa. I could teach him about organic. Pam Tadros, just one of the most amazing people I've ever met. Among many accolades and things that she's done in her life, she designed the interior of our Slinger lab with a guy named Chris Gilmore, who is ADHD. So the fact she survived that is amazing. The fact that they're married is even more amazing. Zach Sersel, he came to me at the age of 11, said he wanted to work in my lab. He's going to come to graduate school finally now at age 18. He's going to start in the fall. It's just an amazing kid. And Prakriti Gaba, she was one of the, I would say, boldest undergraduates ever. She was in Chem 41 and just decided, I go to Caltech. There's not many students to faculty. And she just started showing up every week to my office for at least an hour. We went through everything we went through in Chem 41. She asked every question she wanted. She was like, nuts to the TAs, I'm going to the source. That was great. I've never had a student since who did that. She's the only one, but certainly memorable and has gone on to become a doctor. Really fantastic. And these are just a few. There's hundreds, if not thousands, of students now that have passed through either the group or through Chem 41 or through 242, and it's really been a joy. Outside the lab, there's a lot that goes on. Our lab has been engaged in trying to reach the youngest students that we possibly can in outreach activities. I think this is, Teddy's preschool. We've judged science fair competitions. We try to do things outside the lab. That's the Caltech baseball team. That's a real Caltech pitcher. That's me playing second base. So thanks, Coach Mark, for letting me jump in from time to time. That's me trying to teach a bunch of 8 and 9-year-olds how to play baseball. It's hard. We fail a lot. And this is a recent endeavor that I'm pretty excited about. We've just started an initiative with the San Marino High School to try to actually have a research course where students will come to Caltech and be engaged in a real research project with students in my lab. So I'm pretty excited about that, and there's a number of Caltech professors involved in that. So finally, some parting advice. Okay, so first, be passionate about what you're doing, about your subject. It's infective. If you're not passionate, nobody else will be. Try new things. They don't always work out. Sometimes they do, but you have to experiment. You have to try things. Otherwise, you'll never know. What I've always said, if I can do this, anybody can. And so, those are words to live by. I remember I told Jenny Roizen and Jen Stockdale that when they were second-year grad students, and they reminded me of it, when they started their jobs as assistant professors. And I think finally, support your students. This goes out to my colleagues, but also to any of you who are going on and will have students. Every one of them is different. Everybody's an individual. Everybody comes from different places, has different backgrounds, but everybody has an inherent value. And you just have to figure out what those values are, and you have to try to let them blossom in the ways that they will. You can't change people, right? You can't turn somebody who is inherently one way into something that's completely different. And you can't mold everybody into little yous, right? They're all their own people, but they all have value, and you have to really cherish that. And ultimately, you have to do what so many of my teachers did for me, which was hope that my students hope that our students do better than we do. That's all we can hope for. We hope that they go off and be happy, and that they're in a better place than where they are now. And finally, we'll leave with Teddy. Don't forget to dream a little. So thanks.
Okay, so we have a little bit of time for questions for Brian, so ask away.
Brian, what do you think about professors who just want to do research and their goal in life is to become a research professor? What What do you think about those two? By the way, I don't think much of it.
Yeah, I'm probably standing right there next to you, Harry. I mean, I think, look, research is awesome. I think we all think research is awesome. But I think that, being a professor means more than that. And I think it really, if you read the mission of Caltech, education is part of that. And so I think it's possible to be a great educator and be in your lab. You're an educator of the people in your lab performing research. But I think if you're good at that and you enjoy that, I don't think there's any reason why you shouldn't also be good and enjoy the other aspects of it and be an educator outside of your lab. So
it's always bothered me with colleagues who desperately wanted to just become research professors and not teach.
yeah.
This seems completely foreign to me.
Yeah,
And I assume
likewise,
you
yeah.
realize what you got out of it. You think the same way.
I do. I always find it weird. I remember, John Wood won a teaching prize once, and the prize from Yale was a term off of teaching. It seemed to be a little, yeah. Whether
Yeah, so follow up to that, how do you balance that, right? Because it seems like a lot of universities, especially R1 institutions, seem to value that research a bit more than teaching. So how do you balance it?
Yeah, I guess certainly in the early days, I really looked at this as a selfish endeavor. Number one, I could use the time to learn really deeply subjects that I thought I sort of knew, but maybe I didn't know them as deeply as I did. So that's why we went crazy with that first syllabus. I was going to learn everything there, frontward and backward. I was going to teach his other class with Jonas. I was going to learn new things through that. And so in that very selfish way, I knew that was going to make my research better just by doing that. I also was thinking to myself, these are going to be the students that are going to join my lab. So I'm either going to teach them now or teach them later. So let's teach them now while they're not yet in the lab, right? Because next term I want them in the lab. So, that's certainly in the early days, that was a little bit of the attitude of how do you balance that and still try to get the most out of it. But I think as soon as I don't know, I always loved to teach, and I loved it when I was in graduate school and was a TA. I loved it when I was a TA as a postdoc. It's kind of an unusual situation, but it's just something that I've always enjoyed doing. And so, for me, if you enjoy something, it's not so hard to balance it. So I think that's probably the real answer there. Yeah.
Do you think that typical organic chemistry syllabus reflects the future direction of organic chemistry?
The future direction. Probably no. Probably not. I mean, I think that a lot of what we teach in an organic chemistry class is stuff it's all stuff that's happened, right? So none of it is necessarily the future. But I feel like and I tell the students this early in the class in 242 that, they're going to be performing cutting edge research from the moment they leave this class. And so they better know what happened before that, right? It's very hard to make, to come up with an idea that's going to be revolutionary for tomorrow's chemistry without actually having an understanding of what somebody thought about that problem 20 years ago. And so I feel like courses in a lot of ways serve that purpose. And the wider the knowledge base, the deeper the chemistry gets, the older the field gets, the harder it is to teach all of it in a term. That's for sure. And so at some point you have to realize you're never going to teach all of it. You can't possibly do that. And so you try to allow students a way to understand the subject so that if they happen to encounter something, they'll actually, they'll have a framework in order to think about that. And so, no, I don't really think it reflects the future of organic chemistry, but I think that the topics that we teach are certainly relevant to what students are going to be doing in the future.
Okay.
That's a hard one.
Okay, so one more hand up back there. One more question.
Yeah.
So in one of your last slides, you said teaching goes both ways between the teacher and the student. So what are some of the most valuable things that you learned from your students?
Oh, I think that's most of what I was talking about. I mean, I think it's how different students are, and how every student looks at problems in very different ways, and they're going to approach problems in very different ways. I'm thinking problems in general terms, not necessarily test problems or exam problems or something, but just a problem in the field. They're going to look at it in a very different way, and I think that's something that I guess I had some appreciation for that going into it, but having interacted now with so many students, that's something that is continually somewhat amazing, that how many different ways people can look at problems, and so that's a big lesson, I think.
Okay, well, thank you for your thoughtful questions.
Thanks.